I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this particular video, we'll visualize how do we sketch derivative of a function. We have 6 examples here. 3 of them are parent functions, as you can see, and then we have another 3 functions. Now these are the examples which you will understand help you sketch the graph of a derivative and give you more insight to the topic. You can always pause the video and answer these questions. Now, let us look into details of sketching the graph of a derivative function of a function. Beginning from the very first one, let's understand that derivative of a function is basically representative of a tangent or gradient or slope at a particular point on the graph. Question number 1 is a straight line which is going downwards. It's like y equals to minus x. So the derivative of this particular function should be negative. That is one thing, because it's going down. Second, it should be minus 1, correct? So I can draw a line right there representing the derivative of this particular function. So it is constant, and from this graph we can say that the derivative of this function is equal to minus 1, right? If f of x is the function given to us, which seems to be minus x, so f of x is minus x and the derivative is minus 1. Clear? So when you know the function, it is easy to really sketch the derivative also. Now look here. We have a parabola which is opening downwards and seems as if it is like minus x squared plus 4, since at 0 we have a value which is 4. Now you will notice that on the turning point, the derivative is 0. So that is the first point which is of our interest. We can see very clearly that derivative is 0 at the turning point. Now you can also observe that on the left hand side, the derivative is positive, right? And on the right side of this turning point, it is negative. And therefore, the slope of the graph should be like a straight line coming downwards. Makes sense, right? With x-intercept being at the origin itself, right? So I think that should be the derivative of this particular function, and we can very clearly see that as we go higher, right, so we have more positive slope, right, and it becomes almost 0 at this point. And therefore, for this particular function, we have positive this side, negative this side. I can draw the derivative of the function in this particular fashion. Makes sense? So that becomes the derivative of the function given to us. Now here is a cubic function, the third one, whose graph of derivative you have to sketch. So how will you do it? Well, at this particular point, which is point of inflection, you can see you can draw a horizontal line. And that means the slope of the tangent here is also 0. So we have one particular point here. Now the other thing which you notice here, that the slope here is negative, right? If I draw any tangent on the other two halves, then we see that this is negative. So clearly we have negative slopes on both the sides, and from the symmetry it seems it is like a parabola, right? So that becomes the derivative of this particular function. Now since we are not given any values, we are not really associating our graphs with the given function, but we are only looking at the function itself. So there could be many variations to this, right? However, in general, it will look like a parabola opening downwards as shown here. So that becomes the derivative of the given function graph, right? Now let's look into the second set. The second set is kind of critical since there are many points here where we may not have derivatives. In fact, you see that all the functions are continuous, right? All these functions are continuous. However, in this particular case, right in the center origin, we have a vertical tangent, right? So if I draw a tangent at this point, it becomes like a vertical line. So we see that derivative does not exist at x equals to 0, right? So at x equals to 0, we find that the derivative of the function does not exist. It is infinitely large. Another thing which you observe here is that on left side it is positive, right? And on the right side also it is positive. So basically it is positive on both the sides, but infinitely large in the center. Also you notice as we go far away, it becomes like horizontal, right? So what you notice here is that the derivative of this particular function will be kind of like this, right? So as x approaches infinitely large value, the derivative approaches 0, positive of course, and as x approaches 0, the derivative approaches a very large value, vertical tangent, so we say it's a vertical asymptote right in the center. Is that clear to you? Now here is the next graph. We have a straight line on the left side of the y-axis and a parabola on the right side. How will the derivative of this function look like? Well, on the left side of origin, since it is positive slope, we have a positive value. So it could be equal to 1, right? Since the scale is not given to us, we can say, well, at this point, we don't know what it is, but on the left side of the origin, it is definitely 1, a positive value, correct? On the right side, we see it's a parabola whose slope increases from 0 to a very high value. So it is going to be kind of like this. You get the idea. So that is how it is going to be. However, right in the center, derivative is not defined, right? You see, at any cusp or a corner, derivative is not defined, and therefore we'll represent that with a hole, as shown here, since it is not known what is going to be the derivative at this particular point. So I hope this concept is absolutely clear. Perfect. Next graph here is absolute function, right? Now in this particular case, you see that the derivative is negative on the left side of origin and positive on the right side. So at this particular point, it is not defined, right? So once again, the derivative at 0 does not exist. Is that clear to you? So that is represented by a hole, right? So we can now show that the derivative could be, let's say, a value which is negative on the left side of y-axis, right? And is positive on the right side of the y-axis. So that is how we are going to get the graph of the derivative of the given function in this particular case. So with that, I hope you have understood the concept of how do we sketch graph of derivative of a function. Even if the functions are continuous, the derivative may not be defined at each and every point. Especially, we have observed that the points are, if you have a corner, right, like this, or a cusp, or if you have a vertical tangent, in that case, derivative is not defined. Perfect. With that, we come to an end of this video. I hope you have understood all the concepts. In case you want to learn from me, you can always send an email on the address given. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.